Hello everyone, in this video, we are going to evaluate the sum of square roots. We use S for this expression. First, we're going to use the sum notation for this sum. So we're going to write this way. Just here, just sum. So n from 1 to 1999. 1 to 1999. Then here we're going to put the general term. So then here just 1 plus 1 over n squared. So then here will be n plus 1 squared. Then plus 1 over n plus 1 squared. Then the next step, we are going to simplify the part under the square root. So we are hoping we can make a complete square so we can cancel out with a square root. Okay, so now let's simplify the part under the square root. Here then n plus 1 squared. So first we are going to make them into a single fraction by doing the common denominator. Then here we have the common denominator, that's n squared, then n plus 1 squared. Then the first term times n squared, n plus 1 squared. So here we have n squared times n plus 1 squared. Then the second term times n plus 1 squared. Then the last term times n squared. Then the next step, we are going to expand the numerator. So this is a complete square formula, then times n squared. So then here we have n to the fourth, then plus 2n to the third, then plus n squared. For the second term, use a complete square formula. So here we have n squared plus 2n plus 1. Then the last term plus n squared. Then the denominator. Then the next step, we are going to grouping the numerator. So we first write n to the fourth. Then group these three terms. These three terms, put them together. So that is 2n to the third. So here is 2n squared. Then plus 2n squared. Then combine the last three terms together. And here we have n squared plus 2n plus 1. So here at the bottom, we keep the way it is because it's already in complete square. Next step, we are going to rewrite the numerator. So for n to the fourth, we're going to write as n squared, then squared. Then for the second group, they have a common factor 2 squared. So take out the common factor. So then inside we have n plus 1. Then the last group, so n squared plus 2n plus 1 is a complete square. So put them as a complete square. That's n plus 1 squared. So then the denominator. So then you can tell actually the numerator is a complete square. So let's see. If we take n squared as a, then here is a. Then if we take n plus 1 is a b, you see here is a b. So then you can tell, so here we have a squared plus 2ab plus b squared. So the numerator can make a complete square. So now let's see. So then here we have the top, we have a, that's n squared, plus b, that's n plus 1. N plus 1 then whole thing squared, then just the denominator squared, then squared. So now the numerator and the denominator both are completely squared. So we can put them as a fraction first, then completely squared. So now we can put them together as n squared plus n plus 1. Then here just n plus 1. The whole thing we do square. Okay, so now we can put this one back to the square root. Okay, so now we have here, so as just the sum of the square roots. So then we have here, so n from 1 to 199. Then here we have the general term, it's just 1 plus 1 over n squared, then plus 1 over n plus 1 squared. Okay, so now we can use this to replace the part under the square root. Okay, so then here we have from 1 to 1999. So then here use this part to replace the part under the square root. So here we have n squared plus n plus 1, and here n plus 1, the whole thing squared. So now you can tell, so square and the square root can cancel out. So now we have, so we have the sum and inside without square root. Okay, then the numerator, that's n squared plus n plus 1. The bottom, that's n times n plus 1. Then the next, we have to regroup the numerator. So grouping the first two together. And here we have grouping the first two together because they have a common factor n. So take out the common factor n. So here we have n times n plus 1, then copy plus 1. So then we are going to split the numerator into two parts. So we're going to split from here. So then from one sum into two sums. Okay, so now let's see. Because the numerator and the denominator, they are the same, they canceled, so that's why the first part just 1. Then let's see the second sum. The second sum, the numerator just 1. Then the denominator, that's n times n plus 1. Then for the first sum, because 1 is a constant, so we have 1,999 items. So that's why this sum just 1,999. Then for the second sum, we can rewrite the inside part. Then we can write this way. 1 over n minus 1 over n plus 1. You can easily check it, okay? So these two are equivalent. Because if we make a common denominator, so top is n plus 1 minus n, just go back to here. And this one called the telescoping sum. So let's expand this sum. And here we have, now let's see. So when n equals 1, so this is 1, this is 2. So now here we have the first term, then 1 over 2. Then when n equals 2, so here's a 2, here's a 3. And here's 1 over 2 minus 1 over 3. So when n equals 3, so this 3, this is 4. So then we have, so this 1 over 3 minus 1 over 4. Then keep going until the last term. So the last term will be 1999. So this one, 1999, is a 2000. So then here we have, here, 1999 minus this one, 2000. Okay, so now you can see, so this one and that one canceled. Negative 1/3 and 1/3 canceled. So this one and the one right after it canceled. So 1 over 1999 canceled with the term before. So then the only term left, that's the first term and the last term. So now we have the following. Then here we have 1999 plus the first term, 1. Then the last term, so minus 1 over 2000. Then the answer is 2000 minus 1 over 2000. So that is the answer for this question. Thanks for watching. See you next time.